Let's implement this one. Oh, it's a temporary. Hmm. Quiet from here. No return statement. Okay, I'll have to return an iterator. Cannot return a const iterator. Yeah, okay, let's just implement it. Insert, well, that requires to construct a new node, I guess. So we have to do just create a new node from value. And then well, actually, I'm just going to test if pos is ends. Then we call pushback. Consider it unlikely because, well, for a large list there's only one end, plus why would you insert end? Insert before the end normally. Well, I mean, you would not do it normally, right? You would call pushback, I think. It seems so appropriate to do that. I have to include utils macros for that thing. And then the iterator is going to be back. Hello, Bale. Now I have to implement back. Well, it can't be too hard. Let's first implement back. I have back here, which is a reference and a reference. I can create a reference from a pointer. What, back is a reference? Wait a minute, that's not what I want. Need to return the last iterator. I'm just going to construct the iterator right here. I don't think there is anything that returns last iterator, the last element. Not really. So you have to return that thing and construct it from, which then must be a pointer to the just inserted node. Well, that would be back, but, or a reference, a pointer to the element that is returned by back. But yeah, might as well use previous. So that is base node previous. Would almost say that that sucks because I just tainted it. I just want to return a new node. I'm going to display this function. I think just push back, creates a node and then inserts it. So let's say insert node. Tainting is specific for adding it at the end. make it easier for the compiler to inline this. Put it before that. So this is pushback node, then pushback node, and then of course we take a node type pointer. I don't even need an allocator anymore. Might as well make this part of base list. Which means we can remove this. Then I have to move size to the base list. So I'm pretty sure it's now part of list. Just a size type, standard size type. Well, okay. Okay, go study. Size type here. Now I have to initialize it in the constructor. It's the constructor of the list base, if we have that. Probably not. No, we don't have that. Size. Pushback node. Okay, let's add this then to the base list as a protected function. actually the same thing here. Huh? Okay, except that no, we still need to insert it now. Inserting before pos, where pos is not end. That should be easy. If pos is not end, then we can assume that list is not empty. Pos is dereferenceable, so it does not have tainted pointers. Yeah, I did get new node. Previous is something, and next is something. Yeah, well, it is a lot like the thing that I already have. Let me just copy that. And then think about it. Maybe this is called pushback node. Maybe I should put it just here, you know. Duplicate this thing, including the plus size. To push back, now we make the insert. Insert node. But then of course we need to pass the iterator that we want to insert it before. To insert something. Insert node. New nodes. Yeah, well, plus, I guess. Well, the order is usually the other way around. And looking at this. New node. And that means that this becomes the pos here, const iterator pos. Okay, so new node next is before pos, so that becomes pos itself. But not just pos, of course. Const iterator is something that contains a pointer. This is so not good. Let me think. Pointer, okay. Const iterator has a non-const node pointer. That is, and next is also a node pointer. So next is, yeah, new node is going to be inserted before pos, which means that the next node is going to be pos. So this should be work. This should be correct. This line. And the previous one is then the previous value, the one that is before pos. So that is pos dot pointer previous, where the previous cannot be tainted because pos is not end. And that is not allowed to be end. Let me add it here. Well, that should still hold. And this becomes the previous of the next pointer of a new node. Yeah, looks like it is cracked, isn't it? Yeah. So, add insert node to list base. In instantiation of insert node, yes, we're going from here. It's private. What? Our pointer is private. No access to iterator. Can use this one. It returns a value type. No, I don't want that. I just want to get a node pointer. Because I need to make the list base a friend. It compiles. It doesn't crash. Let's print it. Let's print it as data references from the list L. No, let's just print it to send it out. Then I need to be able to print data to begin with. Now that look good. So this was begin and end. No, this was begin, and then we inserted before it, and this one was inserted before end. It works like a charm. I don't know Python, no. Lyrical place. Okay. Yeah. Now we need to implement all the other things, which is painful because it's so many. I think it's class lists that we need here. This one, and then start at the top, or where shall I start? constructors. How about a copy constructor? I think I'm going to ask Claude to help me here. Let's have a look. Cut. Let's first make a new project. Start a new chat. Use project. I guess this one. And add content. Can you just upload a file? I think I can. Okay, window test or projects. AX test suite utils list.h. And then we say I started the implementation of a doubly linked list in C++20. See attached artifact. I want you to write an implementation for the copy constructor, and only the copy constructor. And put that implementation in a new artifact. Do not change the existing artifact. Okay, let's have a look. If pushback could throw, I guess it can throw, right? It's allocate memory. I mean, it's like pushback, yes, not no except. And if a constructor throws something, then it has to undo what I did before. I'm not sure, however, why I would call clear here. Maybe it's correct. It's in the description, Mikram. I'm writing my own doubly linked list with certain features that are not part of standard list. I don't know if the throw is of the try catch is necessary. I just want to see that in the implementation of I guess maybe it mentions it here. Where's my copy constructor? Here, 6. Copy constructor constructs a container with a copy of the contents of other the allocators obtained as if by calling select container copy construction other get allocator. I'm not using Python, no, this is C++. It calls other alloc. Guess we must have a get allocator. Yeah, get allocator. Do I already have that? Not found. Shocking. Zip. Assign range. Assign is missing as well. I don't know. I've been coding in C++ for 30 years. So you pick up certain things during your lifetime. Just basically doing nothing else than work on the PC, and then you get better and better. Kind of surprised that getAllocator is supposed to return a copy. Why the hell? I don't see the allocator associated with the container. No, it doesn't. It returns a copy of it. It is ridiculous. Maybe, yeah, I don't get it. Allocator type is returned by getAllocator const. And allocator type is allocator. So, well, if C++ reference is not wrong, then this is how we have to implement it. But it's weird. Definitely weird. And then the other thing was as if calling. That was the copy constructor. Copy constructor constructs a container with the copy of the contents of other. The allocator is obtained as if by calling. Allocator traits select on container copy constructor other dot get allocator. Well, let's hope that the copy does not include all the memory that was allocated. It's not a deep copy. It's probably something cheap. But yeah, no. Anyway, then I like this solution. Just access allocate directly instead of making a copy. And apparently, I mean, that's not the same though. It makes changes to it, for example. But I suppose this works. Oh yeah, and then the question was, what happens if it throws? Exceptions. Calls to allocator allocate may throw. No example of implementation. I guess we'll have to look in new tab. Okay, where the hell do I find the standard list? Nobody knows who standard list is. Let's do something wrong. So I'm gonna go here. Let's create a standard list from conform nonsense. But that might actually work. It's just it's on the list int. Yeah. Okay, now I'll use this, and it's not gonna work, I hope. Okay, so apparently standard list is defined in this file. And I want to find the copy constructor. I'm gonna look at get allocator. Still don't believe it. Yeah, it just returns it like that. Okay, whatever. Copy constructor. Empty list. Yeah, you can steal a lot of code from this. Why not just copy all of this? Here's the copy constructor. Choosing M initialize dispatch. Really? You sneakily add something that returns it by reference. That's what I suspected. List implementation. Maybe it's me, but I always had the feeling that these standard implementations are unreadable. Why does it have to be this difficult? Oh, that's also a way to get the type. No, it's not a type. Never mind. It's a way to get access to the base class things without needing the this point or something. Yeah, okay. Copy constructor less. Copy constructor was doing it's called initialize dispatch. Can and false type. It's not even defined here. Okay, this is unreadable. I seriously, I mean, I could put time in to get C-text to work, so I could jump to this thing, for example, and then maybe eventually understand it. But nah, I hate this. But I still want to know if the thing throws. So really find slash user include C++ 14.2.1 type F execute grep initialize a dispatch. It's not being defined at all. How the hell did I do that? It's probably defined in a way that you can't search for it using a macro or something. Okay, let's implement the thing. I'm not totally agreeing with this though, but we'll copy it. So copy contents, and then go to my list. Copy constructor, okay, I can add it to the end. That was too big to add it here. I'll add stuff in order, therefore Okay, to put const on the right. That's because I have that in my project. That's nice of this thing. I should add also that I want my braces to be lined up, open and close braces. And here I didn't do it. Snore. Let's begin with testing if it compiles and works, and then I'll fix it. Well, it doesn't even compile. Actually, that's my problem. Still have the junk in here. Yep, it does. Let's make a copy. So list type L2, copied from L. And then see if that has the same content. Clear is not defined. That's true. List. Oh no. List. Done. Clear. I'm so not happy with doing this in a loop, man. Come on. Why do so? Suppose you have a list of 1,000,000 elements. You don't want to do this 1,000,000 times. You just want to get rid of everything. Must be possible to do it way faster. Let's just use Google. It's about new and delete. You gotta be kidding me. Yeah, right. So in theory, every call to allocate can just be a call to malloc. So you have to deallocate every pointer separately. Unless, of course, we would do something like allocate multiple elements at the same time. But then I would implement a memory pool inside my list. Not going to do that. So we just have to trust that deallocate is super cheap if we use the appropriate allocate. But yeah, I still have to call a deallocate then for every element, apparently. So that has to be in the same loop then as we call destroy. This seems kind of nonsense because, yeah, well, the only reason that is done is because inside the loop it's using that again. Okay. Clear. Well, not clear, but empty. Empty was part of the base class, so that needs this. No type, set a cast, that won't work, I think. Or did I friend the thing? We'll see. This base node. Probably. Base node. I'm using a list. Yeah, I could use this. It's probably the same thing, isn't it? I guess it's the same thing. Maybe I should use this, that is more common. Only have a few of them. Only had two. Okay, why is it casted to a node type? Base node next is already node type. And then node itself should probably required to be a node type to be able to access next. Unless list is a friend of it. Wait a minute, a friend of yeah, the thing is just public. Once you have a node, I'm inclined to use value type here. And then do the cast just once. Maybe just call it element. Okay, and then we have this taint. That's nice that it used taint. Looks correct. Let's see. In clear, still not correct. Required from node is an inaccessible base. Yeah, thought so. Just can't do the static cast. Keeps being annoying. That's a static thing. Totally going to use list base here. Talking about static. Node costs. Only the costs are static. Okay, costs. So yeah, I should do that here as well. Probably. Okay, basically these are just pop the front here. So not a member function that's called pop front in list. Pop back, pop front just exists. Pop front removes it but doesn't return what? So we'll make our own pop front that does both, or normally, well, you could just, normally would get the front and then pop it. So they would be getting it and that is popping it. This is pop front. Yep, there is a front, I think. Pop front. Where's my font? I can just use begin, of course. There is no font, you have to use begin. There's a font here. It's a reference, not super useful. Reference to the node. A good, well, you can turn the reference into a pointer again here. I guess. It should work. Or I can just keep this line. Let's replace this with pop font. Because we don't have access here. And then the list base needs to get a new thingy called protected. Pop font. I could do using pop font, or should it just work? Sorry, I already did have a few others here. The size and stuff worked, I think. Should work. Okay, can remove this. Of course, now it's just in the base class. Base node next becomes next, or node was base node next. Which even works if the list is empty. Then it would pop nothing. Oh, I'm saying that, but this is of course not the correct pop font. We have to decrement the size normally. I already set the size here. I need the fake pop font. A private pop font. So a pop font without updating the size. Okay. Remove front. Probably should inline these things. Move them below all of this. I don't know. Hmm. No, nobody knows where the pop front was. Front, below pop back. Push front is that, dude. Pop front. Before the resize. Oh fuck, I don't have to do this. Yeah, that makes you really wish that the base class had a pop font. So I'm not adding it here. I'm just going to remove font. So add the pop font here. I think that works though. So let's say from the second one we're going to remove the font. Basically test if it compiles to begin with, but I'll do pop font. No, that worked. Yeah, and that was also a test for the copy constructor, I suppose. Yeah, that is definitely a problem here. If you do a pop front, which calls extract front, and it was the last element, then we have to update previous. That's a special case. Base node previous, I mean. Do I have to special case that here? I'm afraid. Yeah, okay. What is next? Move constructor. Yeah, pretty good. Pretty good. That's not bad for an AI, I would say. I hate to have to test this though, but we'll very shortly test it. Should just create a new list. L3 from L, and then assert that L3 is empty. And why not? Let's assert that L3 begin equals L3 end. And while I'm at it, L3 begin is end. And I meant L, of course. L3 size equals 3. No, let's print it. No, that worked. Cool. What is next? Assignment operators. Well, I would say, what is this with the default? All can't be right. No, it's not right. We first have to clear it. Anyway, the AI was pretty good, so I'm gonna ask it to do these two as well. Very good. I'll write a new artifact for Yeah, why not? But I wonder why it's not using the move constructor and swap here. Did do that here? The move constructors is not doing anything if this equals other. And it steals the whole list. Okay, this is kind of strange. Oh, wait a minute, no, it's not strange. Move the allocator. Move the allocator and the base, and then just steals the list and resets the other list. And here we move the base and the allocator. The size is part of the base, so this is basically the moving the base, then assigning the base. Move assigning, I guess. Okay, the clear is necessary. That is true. And all this code is a duplicate. Okay, well, let's ask it why it did not do that. Since you use swap in the first, why not? definitely. Question is, can I move one circle through? Nope. Okay. Yeah, let's just do that like that. Now we have to implement swap. sure this compiles. Let's see, template arguments. I thought it would understand that. No, it doesn't. Of course it doesn't. Total. Wow, undefined reference to. Yeah, I removed that. Undefined references to list, or even okay, destructor. Is that a new artifact for the destructor of list? Oh, totally believe it, aka. So a destructor is no except by default. I don't think you have to add that here. Well, that should do it. Yep. Code dump, double free or corruption. It's trying to destruct L3. That's strange. I printed it. It should just exist. I have no idea. I have no idea. What the hell is wrong? Okay, now you can ask the AI, did I do this right? But I think it's extremely biased to say that humans are right, so not sure if that will help. That's so cute. It uses two spaces. I hammered it in that it had to use two spaces for indentation. It now makes a point of saying that I follow my own formatting rules. Just that's happened. Oh yeah, oh yeah. These are my style guidelines. So yeah, it's totally happy. However, I'm not happy because something is wrong. Okay, please update the list.h artifact with the new attachment. This is the last implementation that I have. Something must be wrong because executing the following test gives me the error that L3 up on destruction is doing a double free. Hi, Kotaro. Yes, but I'm implementing a doubly linked list now. What's with this? Swap the contents of this and other. Swap base node, swap size. Why would we do that like that? Doesn't use the base class and move constructor, which was causing the issue. Right. Yeah. So, no. Well, oh, the move constructor. We don't have a move constructor, so it was the move constructor was actually equal to a copy. So yeah, the move constructor of list. Is using the move constructor of the base class, and normally that should reset then the pointers. So it should make the move thing empty, but it doesn't because it doesn't exist. So it uses the copy constructor. So this makes a copy of the list base, including the base node. So that's just you just have a list that two lists now that own the same nodes. So the AI actually found the error. Wow, I'm impressed. Yeah. On the other hand, afterwards it is reset here. It doesn't own anything. It's just pointing to itself. I have the description in the description of the video. So if you scroll below and you read the description, then you see what the answer is. Already implemented all that. I'm just implementing the billion member functions of a list, which is a very boring. Basically. Not very exciting, let's put it that way. Well, I can't wrap my head around it, apparently. I don't see the problem anymore with using the copy constructor for the list base. No. But it must be somewhere here. If you comment this out, obviously, because it happens in the destructor of L3. Well, Kotaro, you can help me with this bug. So this code here, if I comment it out, oh, now it's an invalid pointer. So it was not just that. Free invalid pointer. Calling clear in list destructor of D380. Now the destructor of L is not working. What the heck? L2, 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 L2. Well, the only thing that we do with L here is making a copy. Still invalid pointer. We did not have that before, so I don't know what's going on here. Insert is suddenly wrong. Well, I made a lot of new ASCII art since I last saw you, but it's all in the source code. Right now I just want to fix this. I think the problem is that, well, the difference between before and now is that we added a clear in the destructor. Before I didn't have that, therefore there was no problem. Even this is going wrong, I think. Just the pushback. There's almost no test left. All for your corruption. Quit, yes. Yep. So L pushback produces a list L that cannot be freed. Should be able to debug that. It copies the temporary allocator. What kind of nonsense is that? I don't know how the allocator works actually, so this is a bit hard for me to follow. Do you get this? It makes a temporary allocator, so an instance of the type allocator that was passed to, well, as to just, you know, the normal STL container allocator stuff. It makes a temporary of that for the default constructor. And then calls list, which is just having using the copy constructor of the allocator. That is a problem. I did, yeah, well, I could put it. I don't like to put it on Git. Well, it is so broken. But all the information you need for this question is here. I mean, is this not wrong? If you make a copy of an allocator? You make a copy of the allocator and then I free both allocators. After, I don't know, this allocator is empty, of course, so maybe that works. Okay, let's ignore this. If you don't do the pushback, that works, right? So, okay, this should not be the problem. It must be caused by the pushback. Yeah, that is probably just standard allocator. Sorry. Oh, what do you mean interface? I'll ignore this. Just continue with the. So you know the allocator is destroyed, but it doesn't even do anything. So apparently that's not a problem. Allocator, I guess maybe the allocator is just empty stuff. It's just an interface for the yeah, but this is here, standard allocator destructor. It's doing nothing. So maybe the size of the allocator is even 0. So we just created a list. Can print a list. So the list contains of the base class list base, which has a base node with the previous and next pointers, which just point to itself, except that the previous one has the last bit set. But this represents the same pointer as that one, and that is the pointer of the base node. So therefore it's empty. Previous and next both point to this node here. The size is 0. And alloc has no data fields. Okay, very good. I was worried about this, but it's the alloc is just nothing. It's an empty thing. It's just just about defining and overloading functions. Just construct that thing. So data is nothing. It's just a 3 trivial copyable POD values. Now we're going to do the pushback. Pushback creates a node with value. Create node. This calls allocate. This allocates one thing, one value type, uninitialized memory. Now that looks like it's on the heap. Now, of course, this can only be freed once. Yeah, so we're probably making a copy of this somewhere, and then free it twice. Okay. Anyway, now we do the construct. So it's like a new with placement in this point, and that should copy value. Just use you should use the thing. I don't know what it does. It's a standard allocator stuff again. Okay, this just casts it back to the protected node base class. So now we have a new node with what this is the node type, is it? Yeah, what? Yeah. So that has I think undefined values in the previous and next. Yeah, it's just bullshit. But then we pass it to pushback node, and that should initialize the pointers. And this value is of course still freeable. It has an offset. Yeah. But if you cast a node type back to the value type, you should get that value, and then we can free it. So I'm going to do into pushback node. New node next is base node. I'm just gonna go through it and then print it, I think. So now we have a list that says, oh, that looks very empty still. No, nonsense. It points to the new node now. So both next and previous, if you ignore the bit here, point to our new node, which is obviously correct. And you can also do base node next, dereference that, and that should point back to the base node. Yep, that looks all good. And the size is 1. It's perfectly done. Step. Step. But it's just not a problem. Everything looks perfectly fine. Now we're going in the destructor, and the destructor calls clear. Oh, okay, bug found. It's using empty. Well, I'm not updating size. Empty test size, and I'm not updating size. So it's just not working. Grid, yes. The size is set to 0 here, and empty is checking size. This is not updating size. So, yeah. I think I'll just make a for loop for, let's say, just the number of elements. I'll probably have to use size type here. Size type. We have to run over all the bloody elements. Yeah, well, shoot. It's a private function, so it explicitly is not, because otherwise I have to decrement size a million times in this loop, while in the end it's going to be 0 anyway. On the other hand, now I'm incrementing a variable a million times. So maybe you're right, and I just should test size. What to do? This increment is as expensive as... Okay. Damn it. I might as well call pop front then. Just do away with the whole extract front thing. It's just kind of bullshit. My extract front would then be a combination of front and okay, whatever. Well, not empty, so this is not necessary because that is done anyway then. And then this must become something that decrements size. So the node is then also not correct anymore. Minus size. Well, although you see, I have to check if the size is equals 0, because then we have to taint the base node previous. And I would prefer not to do that in extract front, because we are calling that in a loop. think that was the reason that I didn't do that. Bum, 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 bum. I'm just too concerned with CPU cycles being wasted. Costs a very large part of my life. I just don't want to do this. Sorry. Does not update size. At least that means that I don't have to branch well, I continuously have to check if size equals 0. We do that here, outside of the loop. Yeah, there is another way to do the test, but I have a feeling that using the for loop is just the fastest way. Yeah, that would be slower, I think. The only annoying thing here now is that we call user code while the list is inconsistent. Is that a problem? The destroy will call the destructor of the elements. If that destructor then accesses the list to do some check, then the size is not consistent. But I don't think I really care. I don't think it should access a list from the destructor of an element. But yeah, you never know. Some people might do that. I'm not sure if that is allowed to have the list be in an inconsistent state at that point. But I could decrement size inside here, but then I have to go the whole way and do this as well. So yeah, if I want to avoid that, you just have an inconsistent list. I really have to call pop front if I want to do that, which is checking decrementing size and checking if it is 0 every time, which is of course not what we're talking about a single clock cycle here per element. It's ridiculous that I spend time on that. Absolutely ridiculous, I admit it. But yeah, now I have this code. Should I make it slower, even though it's just a nanosecond slower? Should I now put time into making it slower while I have this? I don't know, man. Oh, is size not declared? Okay, that works. So now let's go back to the list test and then remove the whole end of thing. Now it works. Now, shall we reprimand Claude? There, thumbs down. Harmful content. Not fact. I don't know. Not factual correct. Yeah. I don't have a job already. I don't care. The smarter it gets, the better. Right. I don't think it will get smart enough during my lifetime or yours. I just don't believe it. What they should be doing with this LLM, the large language models, is just interpret English. And then feed that into something totally different. Which is actually intelligence. And that thing doesn't even exist yet. This is just the language processing unit. Yeah. Write a sign. I hope that at some point it will go faster. But I'll try not to look ahead too far, otherwise I get the demotivated problem. Well, it does help a little bit that write a new artifact that implements. I mean, no. At the very least, it saves a lot of typing. We can think about it if it is correct. Assign count this adds to the end. Clear and then add to the end. Ah, okay. Okay. I go to well. However, everyone hates post-incrementing an iterator. So I'm going to slightly rewrite this, I think. Nou ja, otherwise we call operator. So now I call this one, which just assigns next to pointer, and otherwise we make a copy. And then call the thing, and then return the copy. Now you can argue that this is probably going to be in line, and then two consecutive. Oh, I did make a bug problem. Yeah, you're right. Does this work? Still like good. Fuck. Why not? Why is this not correct? I mean, if current equals last from the very start, you don't want to do anything, right? So that's taken care of. If current is not equal to last, then really it has to become last after doing plus things. Otherwise, you I don't know. I think that's a prerequisite. So if current is not last, I am allowed to do minus followed by plus with my iterators, independent of this is a dereferential bool or not. Because operator minus on my iterator assigns previous. Okay, that's not true then. That could be a tainted previous if it is the first element. Okay, I can't do this. Waiting for Kotaro to say yes. Now it looks good. At least we have a pre-increment. So this is just the assignment. Pointer becomes the pointer next thing. PTR is PTR next. And then if that is unequal to last, then we can continue. Yeah, you're probably right. I could also do the test. I mean, this. Yeah, you're right. What did the AI tell us? Bloody hell. In the end, you're just going to arrive at that. Okay, I defeated. I feel completely defeated. the semicolon looks so weird, but in the end, this is indeed what it is. Yeah, and I don't know. I see this empty thing, and then I think, well, let's make it a while loop, and then you have to do all kinds of things that in the end turned out not to be better than this. Interesting. Wow, after all this effort, you still write a post increment. Yeah, right. The whole point is that I want to use pre-increment. Well, probably a post increment might be optimized away if you don't use the resulting value. Okay, yeah, but you're right. But yeah, this works too. It's just because current already exists. Yes, I know. You're right. But now I hesitate to make this one extra line with braces. Well, this kind of works as well. If you assume the current is just this empty because current is already defined, and then the rest of the loops looks actually pretty damn sane. So our overlord AI was right. Pushback. Current. Okay. Yeah. What about this one? Assign. This is okay. Is this how it should work? I suppose so. It just feels so bloody slow, you know. I mean, the whole reason that assign exists is so you can write an implementation that is faster than doing a pushback in the loop. So what should happen here, I think, is we allocate all the memory at once and then fill it in. So calling pushback in a loop is just ridiculous. But if you allocate everything in one go, then you can't deallocate it anymore, of course. So if you do that and then you delete one of them in the middle, then you can't deallocate that. So that would be, then you have to kind of write a memory pool management system just for the list. So let's not do that then. And this assign in an initializer list. Is that by value? Well, I guess it is, because by default this is from the C++ reference, more or less. So that takes initialize list by value. And then just use this one again. As as long as it works, right? Let's just go on. Let's implement front. I think you can do that in one line here, right? Return. We work very much with pointers, so probably have to get a pointer and then dereference it. And the pointer is... I don't need allocators for this. Wait a minute. Assign, does assign need allocators? Assign calls push back, which needs an allocator. And I think that then push back is part of this thing here. Yeah, push back, pop back, push back is here. So, okay, but front does not need front doesn't need allocators. I'm gonna move the front and the back and begin and anything that doesn't allocate anything to the base class, I think. Okay, man. Thanks for hanging out. Okay, I'll try. Static cast that. So the base class at least can just do a static cast. I'm not even going to call the value cast thing. Just do the static cast right here. In fact, I'll keep working with pointers and then do the dereference at last moment. And then this is a pointer. And the const reference is pretty damn the same thing. A const, yeah, why not, right? Reference up, yeah, should work. Try to compile it. Does not work. Reference does not name type. Oh shit, really? And I cannot just move this, yeah? For some reason that doesn't work. It is quite weird if you ask me. Pointer, const pointer. Well, if you look at the rest, I could do using, maybe. Using instead of, well, yeah. I already have a pointer on a reference. Oh, this is a concept. Value type here. Book. Oh, but I need my value type first. Value type. Oh shit, allocator. So pointer and const pointer require allocator. Ridiculous. What kind of nonsense is this? Okay, so we can't have those. Allocators, yep. The reference is then probably, I think I can just do using reference like that on the list base. I get completely different pointers here. It's a value type pointer. But yeah, so a reference was defined as reference. A reference is simply a value type reference and pointer. No, in the iterator it is. Yeah, but here as well. Reference is a value type reference. So what's with the pointer? Why would the pointer be different? Stupid. Value type pointer. So we can add a const. I bet I can. No, these are the same things. The rest should all work. I'm not using pointers anyway. Let's see if this compiles. Reference does not name a type. And place back. Right. So that did not work. Okay. The reference is const reference. I already implemented these things. I think that this should also be in line, of course. Okay, never mind. Where's the base? So that is begin. Let's move that up and inside. Yeah, whatever. Why is that even compiling? Oh, I'm seeing reference and I read iterator, like here. In end, why is that compiling? It should not be compiling. Okay. Iterator. The concept is an explicit, has an explicit constructor. Yeah. Oh, huh? No. Huh? Right. Now I'm confused. So this is not necessary, you're telling me. Well, I can do it like that. Then that should hold here as well. That's what I mean. No, it doesn't compile. What is something else? What the fuck? What's going on here? Converting to iterator from initializer list would use explicit constructor. Damn it. Why? Just tell me the line number, man. This line number here, 202. And I have to click on that. Doesn't even look like that. They screwed it up. I want back to the old errors. So now it's called an initializer list. And if I do this, and I guess it still doesn't work. It should also be an explicit problem. Still the 202 problem. No, I give up. I give up understanding this. Trying to. So I have to add them here, and this compiles. If anyone can explain that. Oh, because this one is not explicit, are you telling me? Ah, yeah, okay, yeah. Okay, I understand it again. But there was another one that I changed, and that apparently works. Although we can never find that back. This is a no, this is explicit. Value type. What the hell? So why is this not in line? reverse iterator. How would I construct that then? Let's try to construct it from the end. I don't know. Constructed from iterator type to the underlying iterator is initialized with X. Iterator to adapt. Doesn't even say what you have to pass. Going to assume I have to pass end -1 instead of end. AKA back. AKA this. But that's a pointer. And I first have to make it an iterator. What is our end then? If I have to initialize this one from end -1, there is nothing in front of begin normally, so the only thing you can do is pass begin here, which means that I should pass end here, I think. I'll just test it out in a second. I'm going to pass begin here, I think. There's a reverse iterator constructed from an iterator constructed from the begin pointer, which is base node next. I can just call begin. Yeah, we can do that. There is an adapter, I think. You can wrap this in something and then you get the reverse thing. But just let's just use the iterators directly. So the reverse iterator. See, there's one missing. Which is missing? This one, the end. So I just have to pass end instead of n minus 1. Or not. Can't do minus minus end. Wow. Guess I cannot. He did? In what context did he insert a screenshot of my channel? Now I want a link. Well, you cannot paste links, unfortunately, here. Because I want to see that, of course. Not that they speak Russian. I thought untamed was static. Apparently it isn't, or what the hell? My node causes that, yeah. Where is my untamed? So it should be static. Bullshit, that is not static. Okay, Winterton. Is it on YouTube? Or what a Winterton Church. This one? Well, this one. 302 subscribers. Yeah, and that is the same one. And then the last one is this one, or is it live? This is 5 years ago, so probably this one. And I guess this is on the one that is... I'll look at it later. Not sure what YouTube would think if I look at and rebroadcast other videos. Before you know it, I get banned and stuff. But yeah, thanks. I'll check it out. This would still work, but it kind of looks weird to me to use a pointer for a static thing, so I'm just calling it like that now. It is a static thing. Other tamed, yeah, that's then also nonsensical actually. Other that's the same type. And even if it doesn't, the taint is just the same thing. Okay, so you can compile that one. printed in reverse. So we're missing one thing. And it's pretty clear to me that we're missing that one. Which means that, I'm an idiot, see. Begin is wrong. Begin is wrong, obviously. Our begin is wrong, let's put it that way. So our begin is... But. Well, at least I fixed the decrementing end, but... so it should be end then. Maybe that was the same crash, so now it works. You should use end, but then the reverse stuff is going to try to decrement it. Yeah, see, now it works. Okay. So I implemented all of these now. And then we continue list. What is the next one that we did not implement? I did one insert, but not the rest, I think. Oh, there's still a lot to be done. I think I'm going to take a break, man. Yeah. I get a visitor in 40 minutes and I probably should do the dishes and stuff and actually eat something before that time. I think that all of these still must be implemented. Shitload. Not to talk about sort. I looked into sort last night, but I thought I could just copy it from the internet. I mean, but then I found that probably the sort that I want to use is called unshuffle sort, and I couldn't find an implementation of it. Certainly not in C++. And the description was almost not understandable. Basically not understandable. So, it's going to be a whole project to write the sort. Yeah, I think this is a good moment to stop for now, because I already did a lot, and I need to be fresh again before I start working on these inserts. So I'm gonna lose a game of chess and then do the dishes. My rating is so low, it's unbelievable. I did win from a 2000 plus player today though. So the game should still be in my history. So this guy is really liking moving the knight. I feel like chasing the knight away again. But if I do this, it just plays this pawn. And then that knight gets a nice position, although I can chase that one back as well. And maybe I get a check here. I should castle first. Just defend this. It's not going anywhere, right? I have to push this pawn. So I want to put that one here, so to keep the knight out. But currently it is already kept out by my queen. That's true. So I thought if I put it here, the bishop just comes there. But, nah, yeah. So I can put my knight here, maybe I can kick the bishop. And then it exchanges. Oh no, I gave away this pawn. Why am I such an idiot? That's why my rating is so low. Oh really, it's unbelievable. I don't see the simplest of things these days. I think I lost. I just gave my queen away. Ah, this is bad. Should I put my queen here or something? No, I could have exchanged it anyway. But yeah. Yeah. Hey, there's a good move. I'm just one move too late. I wanted to push this pawn and then play that and bishop here. Now I lose my second pawn. Yeah, lose it anyway. Let's use weird stuff. Let's do weird stuff. So come take here. What is annoying? And I can't go here, and if I do that, the night comes there. Probably comes there anyway. Oh, I'm pretty dead. Pretty dead. You can give check here and then dead. Shit. I have nothing. Check, checkmate. No, not if we go here. Give check a go here, right? Oh, yeah, no, brilliant. Yeah, like I said, let's lose a game of chess and then I'll go do the chores. Life sucks. Chess life sucks.